Hello, we're looking at the pre-calculus textbooks, lesson 9.3, which is on parabolas. Specifically, we're going to be looking at example 4, which is found on page 905 of your textbook. However, before we do, we need to kind of have a little bit of understanding, so it would be super important that you read and look at the lessons and pictures and examples of everything leading up to that. You can't just jump into a problem, especially one in this particular section, without kind of knowing some of the preliminaries about it. So this little chart right here, which is above number 4, is very, very important, and it's trying to tell you a couple things. One, this is the standard equation, but we have to understand that parabolas open sideways as well as they open up or down. Okay, so there's two different kinds of parabolas that we have to take into consideration. If the y value is being squared, then it is a up and down parabola. If the x value is being squared, I'm sorry, I said that backwards. When the y value is being squared, we have a sideways parabola, and when the x value is being squared, we have an up and down parabola. Okay, I try to remember it as the one that's not squared is x, so that means it's x goes left and right, so this parabola is going to go x left and right. Y is not being squared, so that's going to go up and down because y goes up and down. Anyway, whatever way helps you remember, this is saying the same thing that I'm trying to do. It's a little study tip. It's just trying to find a way for you to remember it for your own mind. However, let's move on. Once we know that, if you take the opposite of what's in the two parentheses, that will help you find the vertex of your parabola for either one of them. Now, we've already talked about horizontal and vertical. The other thing that's important here is that part of the definition of a parabola is that it is the same distance from a focus as it is a line called a directrix. So if you'll notice here, here's this parabola here, the vertex, then you have your, your vertex is right here, your focus is right here, and your directrix is this line right here. This parabola, anywhere, any point I were to pick on here, would be the same distance to the line as it would be to the focus of your parabola. So that is the definition. That's what defines what a parabola is. Now, how do we know what that distance is? Well, the distance from the vertex to the focus here is always the same as from the vertex to the line of directrix, which is right here. And that value is called P. Now, where does P come from? P comes from right here. It's the number out front of the parentheses. When something is in standard form, it's the number out front of the parentheses in front of the one that's not squared. So whatever that value is, it's equal to 4p. So say, for instance, that it told you the line, the number out front was 8, then you would simply set 4p equal to 8, and you would find that p equals 2. Okay? Now, a couple of things. Depending on whether it's a left and right parabola or an up and down parabola, what you've got to remember is that if p is greater than 1, it's going to open to the right because you're going to go in the positive direction. From the vertex, you would go p value to the right, and that's how you would find your focus. If p happened to be negative or below 0, it means you're going to go in the negative direction, which means that it would open, because it always opens around the focus, so it would be opening to the left. Okay? Same thing for a parabola that is up and down. If p is positive, then the focus is going to be above the vertex. If p is negative, then the focus will be below the vertex, and then that means the parabola would open downward. Okay? So there's a lot of little information that you've got to know pretty well before you can just jump into being able to work a problem. Example 4 says, graph the parabola with a vertex at HK. If it doesn't have a value attached to the x and y, it simply does 0, 0, and that's what some of the previous examples are about, but I thought I would jump into this one. If I have x minus 3 squared equals 8 times y plus 1, This is going to be, of course, a vertical parabola. Just keep that in the back of your head. So when you see this, first of all, you're going to take the opposite of this number, which means your h value is going to be 3. The opposite of the 1 attached to y, really a minus minus here, would be, of course, plus 1, which can be expressed as minus minus. Either way, if you'll just think in your mind, take the opposite of that one, take the opposite of that one, you'll get negative 1. So your vertex is going to be at 3, negative 1. Okay, that's where your vertex, and that's a very, very important point of a parabola. Okay, so once we establish that the vertex, this is the top of the next page, is 3, negative 1, we can find both focus and the directrix. So on our graph, we're going to graph 3, negative 1, which is right here. All right. Now, notice, like I said before, the value here in the equation they gave us was 8. This is equal to 4p. So if I set 4p equal to 8, then p is going to equal 2. Since I know this is an up and down parabola, I'm going to go to my vertex, and I'm going to go up 2 spaces, and there I will put a point, and that would be my focus. That if I go 2 up from there, it's going to end up being 3, positive 1. So that's how you find your focus. Okay. Now, the directrix is going to be the opposite, but the same value, that same p value. So I'm going to go 2 below, and I'm going to draw a line, because a directrix is not a point, a directrix is a line. Since it's going left and right, it's going to be y equals, and again, if I drop 2 points from where the vertex was, my y value is going to be negative 3. So here's my directrix, y equals negative 3. And then you can always then just sketch your parabola. The parabola always curves around the focus, or in the direction of, it will never cross the directrix. Think of that as a barrier line that the graph will never cross. Okay, so that's how you do it. I know they're telling you to do k minus p and things like that, which is absolutely true. Nothing wrong with that. But I think it's much easier to graph your vertex, and then if you know it's going to open upward because p was positive, you're going to go 2 up and make a point, and then tell me what that point is. You're going to go from the vertex 2 down and make a line, and then tell me what that line is. I think that's much easier to visualize than just trying to follow a formula for that. Okay, and here they put it in. They solve for y because that's the only way to put it in your graphing calculator. This point right here, and you can see when they put it on the calculator, it came out to be the same one that we graphed up here a little bit earlier. Okay, I hope this was helpful. Parabolas can be complicated because there's a lot of things to have to remember. Anyway, go back to your chart, use that as a guide. All right, best of luck.